Alright, we're going to go ahead and get our date, page number, title, and learning target down for today's lesson. And we're going to talk about multiplying and dividing rational expressions. And remember, rational, think ratio, or think of fractions. So first we need to review, before we start any of this, how to actually multiply and divide fractions. So if I was to multiply the fraction 3/4 times the fraction, let's do 2/7, what would the process be for that? Well, the process for multiplying a fraction is you multiply straight across. I would get 6 over 28, and then if I can, I simplify that, and I can, they're both even, so I end up with 3 over 14. That's how you multiply fractions. You multiply straight across. So let's just stick with multiplying fractions for now. We're going to multiply this rational expression. And so we have x minus 7, x minus 1, and then this and this. So before we start multiplying straight across, I want to break it down and simplify it as much as I can, just like I did before. So first I'm going to check and see, okay, this x minus 7 is a group. Can I do anything to that? Is there a GCF? Can I factor that any further? And the answer to that is no. That's as simple as it gets. Next, I'm going to check this one. Can I do anything to that? Is there a GCF? No, the only thing I can take out all those is 1, so I can't factor that anymore either. Now I'm going to look and see, can I factor this? And this one I can, because that's 2 terms, and they're both perfect squares, and that's subtraction. So actually, when I go to factor this, this is a difference of squares, which is the square root of the front plus or minus the square root of the back. So the square root of x squared is x, square root of 1 is 1. So this factored is this, okay? And then I check and see, can I factor this? Well, there's a GCF, and so yes, I can factor it further. The GCF in here is 3. When you take something out, you stick it out front, and what's left over is x minus 7. So that is this piece factored. So I'm just going to rewrite it. All is one giant fraction, because when you multiply straight across, that means this becomes the entire numerator and this becomes the entire denominator. But instead of writing this, I'm going to write the factored thing, because those are the same thing. Write that a little neater. Okay, so that's the top of the fraction. If I multiply straight across, that all of this is on top. And then the bottom. This one didn't change because I couldn't factor it. This one factored over here was 3 and then the parentheses x minus 7. So instead of 3x minus 21, I'm going to write it this way. So now I'm going to look and just see, is there anything that can cancel? Is there anything I can get rid of? Well, x minus 7 cancels, and x minus 1 cancels. So the simplified version of this ends up being just x plus 1 on top, and you can leave it in parentheses or take it out. That's up to you, all over 3. Now let's talk about division. So if I asked you to divide, let's do 3/4 divided by 2/7. Okay, when I go to divide these, the rule for dividing fractions is you leave this one the same, and you actually multiply by the reciprocal. So you flip this. So you change this to multiplication and flip this one around, and then you multiply. So in dividing, when you divide fractions, this turns into multiplication and you multiply by the reciprocal. So you flip this around. So same, switch, flip. So now I can just follow the same rules as multiplication. I multiply straight across and get 21, multiply straight across and get 8. But before that, because this was division, I had to do same, switch, flip. and that doesn't reduce. So now let's apply that to polynomials. I'm going to rewrite it before I even start moving anything around. So I'm going to leave the first one the same. And dividing is the same thing as multiplying, so I'm going to change this to multiplication, by the reciprocal. So I'm going to flip this around. X plus 3 on top of x minus 4. And then I'm going to do the same thing. See if I can break this down. And I can. It's got 3 terms, so I need to find what multiplies to give me negative 8. And adds to give me negative 2, which would be negative 4 and positive 2. So that's that one broken down. Now I need to check and see, can I break this one down? And I can. Those are 2 terms, both perfect squares. So I get the square root of the front plus or minus the square root of the back. So that's that one broken down. This one's got 2 terms, but that's not squared or cubed, and that's a plus sign, so I can't do anything with that. And then this one, same thing. There's no exponent on this, there's no GCF, so these are not perfect squares, can't do any more with that. So let's rewrite it, and now it's just straight across, which means I can write this factored. So I'm going to go ahead and skip to writing this instead of that. And I get x minus 4, x plus 2, because that's what this one's numerator is factored. X plus 3 didn't factor, so I'm just going to bring that down next to it. This one, I'm going to go ahead and put the factored version. And then again, this one here didn't factor, so I'm just going to bring that down. And now I'm going to see what all cancels. X minus 4 cancels, x plus 3 cancels, so my final answer simplified is x plus 2 over x minus 3.